Hello folks, and welcome to this lesson on the pH of buffer solutions. By the end of this lesson, you should be able to calculate the pH of a buffer solution. Now in the lesson talking about buffers, I talked about how to make a buffer, what you need to make a buffer, how a buffer solution works, and so on and so forth. Great, good. But usually when you have a buffer, you want it to stay at a specific pH, in which case you probably want to know how to make a buffer that is going to be at the specific pH it is, and if you do make changes, how that pH is going to change. So that's this lesson. Now the simple bit is going to be the way that you calculate what the pH or pOH of a buffer solution is you take the Henderson-Hasselbalch equation, you toss in your numbers, and then you calculate what the pH is. So if you're given the quantities that make up a particular buffer solution and the identities of what you're using, you should be able to use those quantities to figure out what your pH is going to be. On the other hand, if you want to make a buffer solution that is of a specific pH, well, at the end of the day, you have to remember that with your buffer solution, you do want considerable amounts of your salt and your acid. So you're probably going to really want to have same concentrations of this. So that means this is going to end up being log of 1, which means that becomes 0. So you're probably going to, if you're deciding on what to make your buffer solution out of, you are probably going to want to find something, some acid that has a pKa that is pretty much the same pH as you want that buffer solution to be. Or on the other hand, if you need anything basic, same thing except with a base. You choose a base that has a pKb that is pretty much the pOH that you want it to be. Now, if you are a high school student and you are learning about buffers to this amount of detail, you're probably an IB student, which means that you probably have been using a data booklet for many of your evaluations, and you know that your data booklet has quite a few equations in it. The weird thing is, this one isn't in there. Of all the equations the IB gives you, they don't give you the Henderson-Hasselbalch equation, and yet they expect you to be able to use it. So the key things that you're going to need to be able to do is you need to be able to memorize these equations, or you need to be able to derive them. And I'll talk about that in a moment. So I'm going to look at the acid situation, but the basic situation works exactly the same way. All right, so we have our buffer system, and the buffer system is basically you have an acid and then it reacts with water and then you get its conjugate base, and then you have considerable amounts of these things. Well, you make your buffer solution, it's going to be at equilibrium, and so if that's the case, then basically the Ka for your conjugate acid is going to be equal to the concentration of that conjugate base, and then times the concentration of your hydronium ion over the concentration of the acid that you tossed in there. Let's log the entire thing. Cool, why did I bother? Well, we know that pHs and pOHs are going to have logs in there, so probably logging is going to be a good step. Alright, we've logged things, but things are still complicated. Nothing looks like what we want it to look like, so let's actually separate that right side a little bit. Okay, so we can separate that right side into this. Now we're seeing some bits that look sort of familiar, but not quite. So what we're going to do is we're actually going to switch places of these two bits. Okay, hopefully you see where I'm going. Hey, that actually looks like pH. And wait, isn't that pKa? It is, isn't it? And then, that last bit we're going to leave as, and there you go, that's a Henderson-Hasselbalch equation. So it is derivable, even if you don't remember what the equation is to begin with. Now, a few key things to note is that if we're using this whole Ka, Ka only works if your system is in equilibrium. And yes, that is true. However, when we're dealing with any of these calculations where you're dealing with a buffer solution and you need to figure out pHs and stuff like that, Remember that we have considerable amounts of both of these things. The point of the buffer solution is that it's not really going to shift a whole bunch, because any stress that you put on it is going to be, the equilibrium is going to shift to get rid of that. And so basically, the whole way that a buffer solution works is that, yeah, you can make a change to this equilibrium, but it's not really going to change. So that means whatever initial concentrations you have are essentially going to be the equilibrium concentrations as well. So yes, technically, whenever you're doing anything with a Ka and you're dealing with these concentrations, yes, they should be equilibrium concentrations. But when you're dealing with a buffer solution and you're dealing with the Henderson-Hasselbalch equation, you actually don't have to find out what the equilibrium concentrations are, because again, premise of a buffer is that these concentrations aren't really going to change that much when they get to equilibrium, and so that is what we're dealing with. There's no point in trying to figure out all of that algebra. Just use those initial concentrations instead of changing into equilibrium concentrations and doing a whole bunch of extra work. So yeah, you can use non-equilibrium concentrations when using the Henderson-Hasselbalch equation, whichever version of it that you're using. All right, so as an example question, you might be told, calculate the pH of a solution that has these concentrations. Pause the video, try the question out. Now, we're literally in the calculating pHs of buffer solutions lessons, so you can assume that this is a buffer solution. A lot of the times when you're given a question in an evaluation, you're going to be told that it's a buffer, but at any rate, we have a buffer solution. We're going to be using the Henderson-Hasselbalch equation. So let's write that down. And note here right now that we have an acid and the salt of its conjugate base. So we are going to be using the pH version, not the pOH version. So from here, look at your references, find out what the pKa of your conjugate of your weak acid is, then toss in the relevant values into the rest of the equation. Then you keep on going, and there you go. You land at wherever you need to be. Now, once again, I'm going to point out, yes, we have a solution where it would probably reach equilibrium somewhere else, but because this is a buffer solution, these are not really going to change all that much, so we're just putting those values in as they are. Probably one of the trickiest things about solving one of these questions is going to be remembering the equation, knowing or remembering to figure out, okay, am I dealing with a weak acid and its conjugate base, or am I dealing with a weak base and its conjugate acid? Because that is going to determine which equation you're going to use. And then keeping track of, okay, this is a salt, this is the conjugate base, this is conjugate acid, etc. and so forth, so that you put the numbers in the right place. So those are going to be the tricky bits. The solving isn't going to be particularly tricky. Now, the last thing that I wanted to mention is what is going to happen if you dilute a buffer solution. Now, when it comes to diluting a buffer solution, if you toss in a bit of water to your buffer solution, it's not going to change pH. So if you take a look at that equation again, if you dilute your solution, the only thing in here that's going to change are these values. But if you're diluting one of them, the other one's automatically getting diluted. And so this ratio is going to stay the same, even if you dilute it. So the pH itself isn't going to change. Now, a bit of a caveat of that is that if you do add a heck of a lot of water, you're going to basically dilute it to nothing. And so you might as well be dealing with plain old water at that point. In a practical sense, something that you do need to be careful of when you're diluting your buffer solutions is that if you dilute it, because the concentrations of your acid and conjugate base system are decreasing, how much of it you have to be able to react to how much acid or base you're putting in is going to be reduced. So the capacity of your buffer solution is going to be a little bit reduced. So you are going to want to be careful there. That's the end of this lesson. I'll see you next time.